Hello, hello, and welcome to WarsawJS number 72. This is our first meetup with jingle. I hope you heard the jingle of WarsawJS. It was composed by Sławiński and done by Dorota and Filip Szczepańscy, and they recorded really this jingle. It sounds fantastic, so professional. I love it. Okay, so what's next? Today meetup organizers and group meetup support is me, Ania, Maciej, and Sylwia in the back end doing all the streaming and videos. Tati and Anna also helping us with volunteering with speakers and with the networking session and social media. What is WarsawJS? I need to make a very short intro. I hope there are some new people with us, and for them is the intro that WarsawJS is a community for everyone. You don't have to be from Warsaw or live in Warsaw to be part of WarsawJS, especially now in COVID times when we do our meetups and workshops online. So we share it to the whole world. It's a community-driven and foundation-driven endeavor. So people who are working with us are volunteers, and we do the meetups very affordable. Meetups are free, and our workshops are affordable. We do it for knowledge sharing, lifetime learning, and create an environment full of respect and support, so everyone can benefit from that. So you can help us with WarsawJS. You can be a member, lightning talk speaker, support trainer to our workshops, volunteer and trainer. Everyone is welcome. So if you want to help to be a part of the community, an active part of the community, you can write to us. Everyone respects the code of conduct, especially today because we have the networking session. The networking session is up to 800 people. Everyone can join, so you can come and talk to our speakers. But remember to respect the code of conduct. So be respectful, regardless of the differences between us. We are all people, and we need respect. So. Just to know that, you can go to our fork of Berlin Code of Conduct and submit your requests if any are needed. At Meetup, we are 5.5 thousand people. Thank you very much for joining us. Thank you, new members, for coming. You can also subscribe at meetup.com to our new meetups, and the sponsors of today. So without them, it won't not be possible to have this organization, to use all the tools and everything, the platform. So thanks a lot to TankClouds, Prisma, FreshOut, PackHelp, Sumo Logic, and Xfang. You're all helping us, and thank you for that. Thanks to you, we can build the community and support developers and future developers in their development. And we have also partners today. JetBrains is funding you licenses for their products. If you want to win a license, go to WarsawJS Slack and take part in the raffle. Also, SysUp DevOps Polska, where Sylwia comes from, are helping us with putting this all together. And thank you very much, District Hall, so Venture Cafe Warsaw, for hosting us today at remo.co, and you're lending us this room. So thank you very much for that. Thanks to you, speakers can have questions from our community members. So that, as I can repeat that, if you want to join the contest and you're still not at WarsawJS Slack, just message us at contact@warsawjs.com. We will add you to Slack. So remo.co is the networking session. It's open already, so you can go there to venturecafe.org. Don't worry about the URL. I will send you now at YouTube. And we also want to invite you for our React workshop. The React workshop is the React workshop is on 23rd of August. Here we have start 10th because the registration already started, but on the 23rd, so next, the nearest, the closest Sunday, but the next Sunday will be for React.js, and you can already buy the tickets if you want. So the workshops plan on 23rd of August, we have React.js, later on 20th September legacy code. VueJS is on 10th at 18th of October, and on 22nd November we have unit testing. You can also subscribe to the newsletter at newsletter.warsawjs.com to know all of it when it's already known. We send the newsletter with all this information and, for example, some discount codes for our workshops. So today, speakers, we have a fantastic group of speakers today. Rafał Pocztarski will start with Fullstack is not enough. Later, Piotr Sławiński about blogging and Gridsome. Piotr Sławiński attends WarsawJS from the beginning of his career of junior developer, so that's fantastic that he develops this way. And also Rakhi Sharma will be the first speaker about components and browsers. Then Rakhi comes or speaks directly from Germany, I guess, from Berlin. Tiago from Portugal will talk about VueJS, and last speaker but not least, Ania Kubów about making games using NodeJS. So that's our plan for today, and I would like to invite Rafał to our session. Rafał, are you with us?
Yes, I am. Can you hear me?
Hello, Rafał. It's nice to hear you. We haven't seen for a long time since today. Tell me, how do you feel?
I feel great. How are you?
I'm fine, thanks. So let's start. You will have a short question and answers session just after it, and I also hope you will stay with us to the networking session just after the networking for more questions. So the session will start just after 25 minutes. So your time is now starts. So good luck, Rafał.
Hello, everyone. My name is Rafał Pocztarski, and my today's presentation is called Fullstack is not enough in the era of DevOps, Docker, Kubernetes, Terraform, and this is not etc. This is actually etcd. It's another technology that is very, very relevant today. Some of you may know me from Stack Overflow, but I will not go very far in that because I always introduce myself this way. A lot of people recognize my avatar more than my face. So if you are active on Stack Overflow, especially reading about JavaScript and Node.js, then you can recognize it. What I would like to talk today is basically how the web development has changed over the years, because I just happen to have been doing it pretty much from the beginning. I was doing my first projects in 1996 and my first backend development in something like 98 or 99. So I have seen a lot of technologies come and go, and I always like to keep track of what is possibly next on the radar. So I will also talk about that, but first, I would like to say what the title of the presentation means really, because first everyone was a full stack developer. Every web developer, actually, web developers were called webmasters those days. It was a pretty nice name. Right now, it's like I don't see it used a lot. So we are web developers, but web development in the early age, in the early era of static pages, was just writing HTML. The styling was done pretty much with GIFs in tables. There was no fancy borders for elements. So you actually had to, if you wanted to style a website using like I don't know, like the content in a border with rounded corners, then actually those corners you had to draw yourself and put them as images on the website. But back then, if you were careful enough, then most of the websites were actually responsive, because we couldn't rely on the resolution of the screens. Some people have been using 640 times 480 resolutions. Some had higher, but the websites had to look good in all of them. So I, for one, was always using percentage units in the website, so they were actually responsive before the term was invented. And they consisted mostly of static pages. It's not like today when you see a static website that is actually static from the server side point of view, because the server is serving just the same static files, but those are pretty dynamic on the client side, thanks to the client side JavaScript. But those were really like pages. Those were forms, those were tables, those were just paragraphs of text. So the servers back then were just actually only places to store those static files and to serve them. So we used actually just like any Apache server to serve static files, and that was it. But first backends were mostly to use the forms on the website, because pretty much every click on the web page was just reloading the page from the backend, and the forms had to be handled somehow. Later, some dynamic data, like data from the database. If you were doing some, like online store, then you have to some e-commerce websites. You had to use some database, and actually everything was generated on the backend side. So the servers were generating HTML on the fly, and it was just rendered by the browser as static content from the browser point of view, but it was dynamically generated on the server side. It was used by CGI. It is a common gateway interface, actually a pretty nice interface. Some of you can remember the CGI bin or have seen CGI bin directories. So this was where you put those scripts. I was doing them mostly in Perl, but there were you could actually write it even in C or in Bash scripts. I actually wrote some backends that were just Bash scripts or C programs for better performance, and it was actually quite interesting to develop the backends that way, because you could create some prototypes very fast. So then you just had to have some server and some place to put those files. So the CGI bin was a convention that the server, when a file from this special directory was requested, instead of serving the files from the disk, it was actually executed them. So it was executing them, and they got all of the data via environment variables and standard input. And they just printed the HTML on standard output together with the headers, and this was just the response. And every time you hit the same endpoint, the program was like restarted from the beginning. So it was stateless. It acted pretty much like today's Lambda functions in the modern clouds in that way. Next, I would like to briefly talk about where we just stored those. How could we actually serve those files? So the really first era was just that people were mostly running our own hardware. So we had to buy a hardware, buy some computer, get some network connection to that computer, manage the network, manage the routers, manage some hubs or some other less complicated network devices, because routers were expensive and hubs were not, but they were not as performant. And we had to manage our own hardware, install from the beginning the operating system. Some people use BSD, SunOS, Linux. I mostly used Linux on my own servers, and I worked at the time on SunOS and Solaris servers, but all of them were basically having Apache HTTPD, Perl. Some were using PHP for the backend runtimes. Of course, the Apache was optimized with some mod Perl and mod PHP modules to make it faster, and no longer making it really stateless. So it had some advantages and disadvantages, but you just had to do everything yourself, from the network connection, from the cable from your network provider to the hardware. You had to listen to the fans on the CPU if they are not spinning fast enough to replace them before the CPU overheats, and the disk drives, if they sounded funny, then you had to be prepared that they are dying and things like that. So it was a lot of things on your mind other than just creating the software. You had to manage a lot of things by yourself. Then the next era was shared hosting, and people were just putting those HTML files and PHP files via FTP on some other people's servers, and those were mostly not secure at all. It was just one. If you wanted to in your own backend code, you could just read anything on the server usually, because it had to be word readable, so the Apache could read it and execute, and Apache was usually run by a nobody or HTTPD user in the operating system, a very low privileged user, so that any exploit would not be very very devastating to the server. But it meant that the Apache had to be able to read your own backend code, and usually you had there, for example, database passwords. So it was very hard to get secure, and users were not really. It was the case that on the Linux system or BSD or Solaris, those systems had pretty good separation of the users, but you had to make your scripts readable by the server, and if everyone had to make their scripts readable by the server, it meant that your scripts could read other scripts really. Another idea was using, so this was like the first idea of cheap hosting of your own websites, and it was pretty good for static websites, not very good for dynamic websites with some backends, because the server, anyone could like bring down the server, and your website was not functioning because you had to share it with a lot of people to make it cost effective. If you were serious, then going from your own servers, you were going for co-located servers, so that instead of keeping your own hardware in your own office and getting a very good network connection, you were just bringing your own hardware to those co-located data centers, where they were just renting you a rack for your server and the network, and you were putting actually your own hardware there. So you had to pass some security and show that this is your server, and they were secured, and you could work on your server, usually paying a lot of money. And I know about it not because I was in such a co-located place, but when I was working in the late 90s on remote servers from Poland in the United States, then the client told me that, and actually I had a task of updating the SSH server on the server, the SSH daemon, SSHD, by which I was connecting to the server. So I knew that if I do it wrongly, then I would never be able to connect it to it again to fix it. So I was just basically, cutting the branch of the tree that I was sitting on. And they told me to not screw it up, because in that case, someone would have to take a plane to fly to the co-located place where the server was running, and physically reinstall the operating system, sitting there and paying a lot of money for the trip and for the time and for even being in the data center. So it was better that at least you didn't have to have your own great internet connection or like UPS, some redundant power, but you still were buying your own servers, and this was very difficult to to predict how you have to scale, because it was not like you could change the idea of how many servers you have in a minute. You have to really buy those servers, and they were really expensive. So the next idea was that the servers were actually rented, so that you didn't put your own server on the rack, but you just actually was renting one of those that were there already. So it was much easier than buying your own hardware, but you had to do all of the other work pretty much the same. You had to install your own operating system, you had to keep it updated, you have to patch the system, to install and provision every software that was there. And so the work was really the same, but it was easier to rent it than to buy it. But it was still your own, and no one else was using those particular servers that you have rented. So another good idea, and this was actually a very good idea, virtual private servers, where when they came out, it was shocking how cheap they were, because you were not renting the entire machine, but you were renting a little part of it. And the real machine was running some virtualization software that was presenting as multiple little servers. So one big server were running like a lot of virtual private servers, and you could rent them very cheaply. But you still had to manage everything yourself. You had to install the operating system. The installation itself was usually pretty easy, but you had to install all of the software yourself. Some time later, it was made easier, but still you were just the administrator of the system. And at that point, usually going to the presentation title of full stack, what the full stack really meant at that point. Usually, if you had to manage your own server, then you had to be like a system administrator and a front-end developer. Even if you didn't have a lot of back-end heavy stuff on your server, then you couldn't really work on a virtual private servers not knowing anything about usually Linux system administration or some other Unix-like system. So pretty much everyone had to just know it, to just put a website somewhere. Another good idea was some provisioning software that came out, like Chef, Puppet, Ansible, SaltStack, that made it much easier to provision software on multiple servers. Like if you had, like, I don't know, 10 servers of the same software installations, then it was much easier to just script those installations than to do it manually. But this was from one point of view, the tools were very good working, but the idea, I was actually doing pretty much the same in the 90s by just writing bash scripts to use apt-get install on Debian or things like that. So the idea was maybe not very good, very new, but the implementation was really convenient. And then came what I call a Heroku era, which was actually pretty amazing time, because now everyone was able to very quickly create a backend for their server or to serve the front end. And what I not only Heroku but also Netlify, Compose for databases, Mailgun for transactional emails, Cloudinary for handling images. Those are excellent single-purpose services, like Unix style, that one tool does one job but very well. And what I call it is the Arduino of computing. So you can just, like, if you want to do some electronics, then if you get Arduino, then you can start pretty much in 5 minutes and do something nice and very exciting. But it's not the case that real world electronics is being built from Arduino. So at the same time, what was really not very nice to work with was the Amazon Web Services, Azure, and Google Cloud Platform. And what I call it is that while Heroku and Netlify are like Adafruit Industries, which is a website to get very nice to work electronics like Arduino and stuff that can interact with it, and AWS and Azure and Google Cloud Platform are more like DigiKey Electronics, where it's not a very nice website. It's not very intuitive. The hardware there is not very nice to work with, but it just has every hardware that you can buy for electronics and for like real electronics, where, you know, if you do some, I don't know, a microwave oven, then you are probably getting your parts from somewhere like this, and you are not actually putting Arduino in there. Not that it wouldn't work, but it would be much more expensive, and you couldn't source your parts as well as using real distributor of pretty much all of the parts in the world. And so this is what I really called AWS and Azure and GCP. It's like real world building factories. It's not easy, it's not fun, it's not nice, it's very complicated. It's not created to make it exciting, but you can pretty much do everything there. Then there were Lambda functions, which is also a very nice idea, but it is actually quite a heavy abstraction, and only supported runtimes can be used there. So you cannot use a language that is not supported. But then, which is right now very popular, Docker came out, which is nothing new if you know Solaris, but very new if you only know Linux. And now you can not only package your own backend very conveniently, but you can also put your own runtime there, and you no longer need to care if the server supports your runtime or your language or version of whatever it is, like Node.js or Dino or I don't know, or a Java virtual machine version that works with your code or anything like that. You just put you containerize your backend, and it works everywhere where Docker works. But and also the Vagrant were much more popular back then, but now maybe less, usually for development, but some people also used it for deployment on the servers. Docker Compose, which is an abstraction of using multiple Docker containers to run them in sync when you use especially microservices, but also in one Docker container you can have your backend in another, a database in another, a queue, or anything like that, a message queue. Now there is Kubernetes, and also this is a very it is a revolution in orchestration of the containers. So you can now build another abstraction over those containers. So you are looking at much higher scale, and you can build a very big systems that interact with multiple services and microservices architectures and external services and databases and message queues and anything. Also, there is Terraform that you can use to create infrastructure as code. So instead of manually provisioning services, you are actually writing code that describes your infrastructure, and you can version it, you can put it on GitHub, you can make a pull request to change the number of servers or things like that. It's quite complicated. It's very powerful idea. There are also custom solutions to do that, like AWS CloudFormation or Azure Resource Manager or Google Cloud Deployment Manager. But as I see, a lot of people are using are preferring things like Terraform, because then you can change the cloud that you are no longer very dependent on the cloud that you happen to use first, and you can change your provider. The future is what I see. It would be WASI, Fastly. It's a very nice company that is experimenting with those things. Bytecode Alliance is something that I would keep an eye on, because I think that even lighter abstraction than Docker containers is needed, and it will really change how we can deploy things and how performant they can be. So this is basically what I presented. Maybe at the end, I will just say that how it relates to the original idea of that full stack is not enough, because today I think that people calling themselves full stack developers are usually front-end developers who also do back-end development, but only like writing Node.js code or maybe Python or other language and runtime. but usually they are not concerned about things like Terraform, Kubernetes, Docker, the native cloud solutions, or Azure deployments, or AWS deployments, or IBM cloud platform. And but it's easy today to create, I don't know, a website using with a simple backend on Heroku and deploy it in 2 clicks from GitHub. But usually what I see that very large organizations rarely use Heroku for deployment of their production code. So at some point, if you really want to be full stack in a way that you just like, or what I sometimes call a even fuller stack, is if you just want to be able to work on everything from your front end back on every level of abstraction, using some backend APIs that your front end directly connects to, but also what you do with those backend APIs, how you deploy them, how you can deploy them on AWS, how you can deploy it on Azure, how you can create microservices architectures that connect with some message queues, like, I don't know, RabbitMQ, or other queues, and how to manage multiple instances of the same servers to scale them, how to scale it up, how to scale it down, how to, the difference between scaling out, and there is so many things to keep an eye on right now, also because the traffic that you sometimes have to handle is so great. Most of the big deployments right now are using microservices architectures, and this is not something that you usually start with when you create some simple node backend on Heroku. But this is something that I would suggest, especially front-end developers who are aspiring to be full-stack developers, to keep an eye on, because I've seen some time ago, I did some research, and a lot of full-stack jobs currently require Terraform and Kubernetes and Docker knowledge, and native cloud knowledge. So this is something that I think is good to keep an eye on, and just to go like fuller stack than only the next level from the front end, because usually people say they are full stack developer because they are doing front end and also the backend API, but not anything below that. But I would suggest going below and seeing how it all works. This is today is very cheap to do, because you can you pay usually by the hour in fractions of cents for services on AWS and other clouds. So this is my presentation. If you have any questions, then this is the time for it. Thank you very much.
Thank you very much, Rafał. Thank you for this awesome presentation. I appreciate that you asked, shared all of this information, important information. I can see that there is a joke on YouTube. I think that's no, it's not. It's the right answer. I don't know. How do you think? It's from the slide.
I will not say exactly what is the right answer, because I encourage everyone to just try it, because it looks like something that you map over 3 the same values, so you should at least get the same the same values on the result. But this is not as obvious as it sounds. So I would let everyone run it themselves and trying to figure out how it works and why.
Okay, we have a question from Arthur. So I will read that. Do you think it is a good career bet to become a fuller stack? Some people say they don't believe in full stack since this is just too much to handle by one person.
Yes, it's a very good question. I myself am focusing on the backend development, and I sometimes call myself a half stack developer because of that. And basically because I think that being a very good front-end developer is like a full-time job, and this is a lot is going on, and you cannot just focus on only one framework like Angular. You need to React, Vue, some newer things like Svelte or Marco, and there are things that you cannot just learn once and use for many years. But I think that if you are going full stack just one level down, then it would be very good to just know more stuff below that, because not to be even an expert with that, but just to be able to understand what is a cloud formation, what is Terraform, how to create some simple Kubernetes configuration for your own containers, how to containerize your application, how to run Docker Compose to quickly check it before deployment. So not to be an expert DevOps or backend developer, but to not only see the one level below the front end, being the usual backend API, but just basically understanding what is going on below that. I don't think that anyone could be an expert of everything. You cannot be the jack of all trades and master of none. But I think that a basic idea of every level of the stack that you are working on is very useful. Some front-end developers are going deeply down and, for example, become DevOps engineers. So it is a rare knowledge, I think. Not a lot of people are doing that because it's not, it's not nice to look at. If you create a front end, you can create beautiful interface, and configuring Docker is, it's not very rewarding. But it is a very useful knowledge, and some companies I see are hiring front-end developers with the full stack knowledge going down to the DevOps level and really Kubernetes, Docker, and cloud formation.
Yeah. I'm happy that you're saying that, especially that Docker and Kubernetes, which seems to be now quite universal between GCP, AWS, and Azure. It's all probably going to be aligned to that, even the less popular clouds. So yeah, that's but still it's a long subject. So I hope we can talk on that during the networking. So I hope to see you in after 8 when we all finish this talk session. So thank you very much again, Rafał, and congratulations, great talk. We will publish this on YouTube, and we will have it later. So now Piotr Sławiński, Gridsome and blogging. Hello, Piotr.
Hello. It's nice to hear from you.
Yeah, I can hear also very, very well. So it's your time now.
Do you also see my screen very well?
Yes, I can see your screen now. Okay.
Great.
Awesome. So let's start. Good luck, Piotr.
Thanks.
See you soon.
Hello there. My name is Piotr Sławiński. I'm a junior front-end developer working at Warsaw Institute of Aviation, and this evening I'll be showing you how to start your own blog using Gridsome. So without further ado, let's install the Gridsome CLI. It's unnecessary on my end, but I will do this for the sake of this presentation. It's quite fast, so whoops. Already a screw up. Well, that's a good sign for the rest of the live coding, isn't it? Okay, next we will create our project. Whoops, that's not. And the name of our project will be Good Enough Blog. This is also taking not very long, so bear with me. I will also install some packages. That will take long, and then we'll get back to slides because that's probably interesting for those who came here to see slides. And this is just a, like typical template for a starter. Okay. What else? What else? Actually, I can show you what it looks like. Or not. Let's install the packages because there's no time. The package over here is a plugin actually from Gridsome, official Gridsome plugin, which gets all the files, in our case, the posts we are going to publish, and loads them into the Gridsome data layer. There's also required another package, another plugin, which is called Transform Remark, which will turn Markdown into a usable HTML. With Markdown, we are gonna write our posts. That's about right. Yep, no typos here. Yeah, and this takes quite a long. Okay, so what is Gridsome? Well, thanks to Rafał, we already know what a static site is or was, but actually it's static sites are back on the menu thanks to the static site generators like Gridsome, Gatsby, and Jekyll, I believe. So they take they render the files. They render the web pages during the build time, and they serve the content directly to your browser. So it is also Gridsome is built with Vue, and it's using the Jamstack way of building websites and apps, which means that it is focused on high performance. The apps built as Jamstack are focused on high performance, low cost, high scalability, security, and also maintenance, which means that the developer experience is quite high. And taking all of the above into consideration, it makes the Gridsome very fast. Okay, but what about the Gridsome tips and tricks or quirks, or what's going on inside? Well, besides being built with Vue, using Vue, besides using Vue, it also uses GraphQL. What? Did he say GraphQL? Oh, yes, I did. When I mentioned about data layer, the stuff from data layer, which may come from CMSs, from APIs, from files on yours, it's all can be taken from the data layer using a GraphQL query. Also, the Gridsome is file-based, has file-based routing, which means that if we take a file like a I don't know, something .vue, and we put it inside a particular folder, bang, it becomes our route. Easy as that. Also, it has progressive images, which means that we can operate on images like we can very performantly change the scale of an image, for instance. And also, when we load the image for the first time, it is being preloaded as a very blurry, low-resolution placeholder, which is then being replaced by a high-resolution final image, which improves the user experience, apparently. And also, it has prefetched. It prefetches pages when clicking on links, because when a link to another page becomes visible on your screen, Gridsome knows about it and starts prefetching the data from that link, which was then, if you click on that link, it redirects you already to the preloaded page, which of course increases the speed of the app. Okay, I'm guessing that it's now the time for the live coding. we are now finished with the. No, we are not. Okay, in that case, I wanted to save up time and not to waste any more of it by looking at the packages being installed, and I made a typo. That's typical Piotr, typical. Anyway, in that case, actually, we might want to spin up the thing which is which Gridsome provides us with at the beginning. So what was the name? A little bit of improvisation. Please work, please work, please work. Any minute now. Almost there. Great. All right. Please pay attention. What is going to happen on the next website? Do you see this blurry image? Bang! It's gone. That's the progressive images. Oh, thanks. That's nice. Well, then everything went south. Thankfully, you did have the opportunity to see the Gridsome starter website. So thank you very much for your attention and have a nice evening. No, I'm kidding. What is going on? Okay, we're still installing the packages. Let's let them finish. Okay, that's it. This is probably we shouldn't build our app during package installation. Well, that's a lesson to learn. Okay, let's take a look what's going on in the code. Oh well, maybe we will fix it later. We have to fix it later. Well, you didn't sign up for a debugging session, didn't you? Me either. Okay. So no, we can't leave it like this. What a skilled junior does when something is not working, he tries it again with hope that it will fix itself. Does anyone have any jokes to share? Oh, that was faster. And okay, we are saved. Whew. That was a close one. Okay. What now? Well, we have some configuration to do. Not this configuration, of course. We have some Gridsome configuration to do. Namely, we need to configure the plugins we just installed. So let's get down to business. And the package, the plugin name was Gridsome /source files system. Yep. Then options, path. Path, it's a property that where we determine the location of our files the plugin will put into the data layer, and it's blog something MD. because you never know what the name is going to be. And also we need a type name, which is a name for a GraphQL collection. I'm not very knowledgeable about GraphQL, but this will change in the future because I plan to make the next talk about GraphQL. So wink, wink. What else? I think it appears that we are all right. Let's change the name of our blog because it's good enough blog. Also, we could consider configuring the transformer, which for the Markdown files, but actually it's zero config. It doesn't. You don't have to configure it for this type of basic stuff. So let's leave it as is. And next, let's make this directory, which we just said the files will be in. So blog, and let's create our first file, first.md. It's not like that. It does not work like that. It works like this. Alrighty. So first, a little bit of YAML header. We need a title of our post. So first post. We need a description because we're gonna display that on our blog. So this is our first post. Okay, and some content. Welcome to our blog. It's amazing, isn't it? Okay. And a little bit of blink. Great. And we're done. Okay. Next thing is we need to make a place in our app to display our posts. So we need some sort of a scaffolding for this Markdown file. So we will use templates over here. We will call it post.view. It's when we put something in the templates, it creates pages for stuff we have in our data layer. So when we have files in data layer, creating a template will allow us to. It will be accessible through. It will have its separate URL. Okay. Now let's create the said scaffolding. Over here we need the layout. That's layout. It's a thing which is required by Gridsome when we want to have unified layout of our app in many pages. Okay, so we need also a div, and inside the div we need a what do we have in the post? Okay, in a post we have a h1, and we also with the title, and we also have a paragraph with the content. Of course, we all know it doesn't work like that. So what now? We need to write the GraphQL query. So okay, so we do it like this. Let's close this. Too bad the editor is not helping. Okay. So the first query will be only for the content, title and the content of the post. So let's name it post. Let's access the collection, and now we need title and we need content, and also we need something which will show us only the distinct post we are actually accessing through URL. So we can do this. We can do this either by giving an ID or a path. Let's do this with path. This over here as well. I think that's about right. No, it's not. It's not all. Okay, so it won't work like that because we need to interpolate the data from GraphQL data layer, which is it looks like this. The syntax looks like this: page post title, and as for the content, the markdown file has to be actually interpolated like this using the vhtml directive. Otherwise, it won't work. So page post content. It appears it's all right. Of course, we will see later. Okay, so our post is actually ready somewhere in our app, but we cannot access it. So we also need a component which will render us a post list. And let's name this file like I said, post list view. Great. Okay, so this actually will be we won't access the data layer directly. We will use props from the parent component, and by that I mean the main index.view. So I probably should have done it other way around. It will be more intuitive. Anyway, you can play the video in reverse, I guess. Alrighty, so that's about it. What do we need here? We don't need the layout tag anymore because it's a part of the index.view after rendering. We need, well, div. We also need, we will be needing the h1. We will be needing the paragraph tag, of course, h1 for the title, p for the description, and also we will need a glink. Glink is the prefetched link I mentioned to you before. So yeah. Of course, this link has to aim somewhere. So it's going to be post.path. It's going to be over here, post.title. And over here, it's going to be, this time we can interpolate, post.description. Yeah. Hey, it looks all right. Okay, now let's get to this index.view. There's a lot of unnecessary stuff over here, so let's remove it. Okay, that's not the title we want. We want this is good enough. Okay. If we want to use a component, we need to import and register it. Components / post list. That's not, okay. I'm not using colons intentionally. I'm just too nervous. We also need to register the components. Okay, thank you, Mr. Editor. And let's work on it. Well, let's wait a little longer because over here we need another GraphQL query because we have a couple of stuff which is which we don't have currently. So page, how's my timer? I forgot to run my timer, so yeah, that's not a great day. Okay, so we have a query. The query we call all post. I think if you have questions about naming, you need to address them to the authors of the plugin, I guess. And in all posts, we have something called edges, which is a collection of nodes, which we also have. And inside nodes, we have the stuff from our files. So first of all, path, title, description. We don't need content because it's already handled in the post template, post file. Registered. Okay, we can start with our HTML template. Okay. We have our post list. So first, let's cycle through all the items in our collection. So edge in add pages dot all post dot edges. Okay, it is also required to put a key over here, so it won't be, well, in application this small, it's not necessary, but it's a good practice to put it anyway. Edge node ID, and also let's pass down the props, and the name of the props is edge, the name, the value it's referencing to, edge node. Okay, hey, that went quite smooth, at least from the typing point of view. Now let's check if the app is crashed or not. Of course it is. Okay, so it appears that we have an issue with our page query. All post edges node path title description. Huh. Why is it not working? Okay, as you can see by the look on my face, the struggle is real. I did not script that. So let's check the error message again. I'll post on type query. No, I meant all post. Okay, you know what? When I'm in a pickle like this, creating Gridsome pages with Gridsome blogs or Gridsome apps, I like to consult a very, very knowledgeable person on the blog behind the very knowledgeable person behind this blog, which coincidentally is also constructed using Gridsome. And actually, whoa, surprise, surprise, there's an article about this process of setting up a Gridsome blog from scratch, and we can consult that actually there is nothing wrong with it. Okay, I will recommend you if anything was if I went too fast on any of the aspect or you need further explanation, please check it out. This blog, it's mine. But what's going on over here? Why is it not working? Okay, last time it did work. I have no faith that it will work again, but let's rerun the build process. Well, the technical aspect of this presentation is very low, but actually, if you want the okay, it didn't crash. Okay, it appears that we are still having problems with index.vue. That's god damn it! Of course, a typo. Ta-da! It is our first post. Okay, it's actually clickable. Of course, the link is broken. Nothing works. That's not a good day. That's not a good day for juniors all over the world. Such an embarrassment. I'm joking. I feel great. It's my cup of tea. Failing miserably before other people. Impulsive undefined. Okay, but why doesn't the blog work? This should be fine. Let's take a look at the post. Page post. And this not right. This is the name. No, the name is all correct. Okay, so how much time do I have left? Oh boy, I think I'm way over time. Okay, listen up, guys. Whoops, sorry for that. Sorry for the infinity well. But hey, maybe we did not install correctly the transformer remark over here. We won't probably be able to. So let's, hey, Piotr, back to the studio. Do I have to debug it right now, or are we like, is the time crucial on this point, and do we have to move to the next guest?
Okay, Piotr, I think you hit the wall at this moment. So
yeah, such an embarrassment.
Sometimes happens. No, it's awesome. I honestly I don't know how to solve this issue. It might be a dependency, as you guessed. So it's probably too hard to fix it now. However. That's how real coding looks like most of the time, and we also streaming video to groups for beginners, and they can all see that it's actually not only a beginner failure to struggle and to hit such.
Do you accept cheating? Because, well, I don't consider this cheating. It's actually a very honest work. I will copy code from the internet.
Okay. I think it's the most solutions look like this.
Yep.
You can use this strong mammoth behind you, whose name is or the other.
Okay. Yeah. So we also need to. At least I guess some of the people in the chat had a good laugh watching me. Yeah. So that fake skill from LinkedIn is I'm speaking about stand-up comedy is well earned.
Okay, let's see us together. Actually, most coding is much easier when you do it together with someone.
Nope, it's
No?
not.
Okay.
It's not
Maybe
that.
not here.
Okay, but as you can guess, this is a. No, you know what? I'm not gonna embarrass myself any further. Thank you very much. My name was Piotr Sławiński. Please remember that I'm not afraid to fail. Failure is actually a very cheap way to learn. So stay healthy, stay safe, and peace out.
Piotr, I hope you will stay still with us to the networking session. And can you go back for a moment? Sorry. And yeah, maybe a question, maybe some questions about Gridsome. I understand you choose this technology because it was better than that one you used before. Can you give me more context why you choose that for the blog?
It was my first time with blogging,
Okay.
so I'm very familiar with Vue. So immediately I researched Gridsome, as I knew it was a static site generator. So and also I heard a lot about Gatsby, but that was not my pair of jeans actually, because I'm not very knowledgeable about React. So yeah, Gridsome was the.
Okay. I think that many people interested in Vue are also watching us because Tiago will talk about Vue. But before Tiago, there will be also Rakhi, and I can see that Rakhi is already on the streaming. So Piotr, thank you very much again. Congratulations.
Yep.
Big applause.
Thank you very much. I will try to
do.
debug it, and I will get back to you or I will solve it.
Okay. So we wait for your links, and thank you very much for your effort today.
Yep.
And now let's welcome Rakhi. Rakhi, are you here with us?
Here. I hope you can see my screen and you can hear me well.
Yes, I can hear you very well, and we can also see your screen. So everything looks like set up. Rakhi, I'm so happy to see you today because we saw each other a long time actually ago live. No, maybe not so long, but it was in London last year.
Exactly. It was in July. Yeah, it was in July last year.
Yes, July last year, and I was totally impressed by your knowledge about engines and browsers because you were speaking there at FullstackCon. So today we have a kind of full stack meetup because also Piotr was talking about the full stack. Now you're more about browsers and the internals of our tools. So I'm very happy about the level today, and good luck, Rakhi.
Yeah, thank you very much. Hey everyone, thanks for joining us today. I am Rakhi, and today I'm going to talk about, for next 5 minutes, I'm going to talk about components of browser. So before I jump into the components of browser, just a bit about myself. I am Rakhi Sharma, and I'm working at Delivery Hero in Berlin, and I'm working here as a software engineer, mostly focused on front end, but I am a full stack developer. But anyway, let's jump into our talk. So as you see on the screen, these are the 7 components of the browser. If you ever Google about the architecture of the browser, you will see this exact diagram with all these components. So in the next 5 minutes, I'm just going to cover all the components in a quick way, and I hope you get an idea about what all these components are about. So when we talk about user interface, I know some of you might be familiar with some of these components, or at least have heard of it, because as a front-end developer, you deal with user interface, interpreters, and everything. And as a backend, you also deal with networking and database. So yeah, let's start with user interface first. When we talk about user interface in the browser, the one thing that comes to our mind is, okay, I opened the browser, and whatever I see on the UI is user interface. But let me tell you here, that's not completely correct. When you open a browser, you see a lot of things: the window and the URL bar, the back and forward button, the tabs and everything, but not all of them are the part of user interface. When I say not all are the part of user interface, that means it is not getting rendered from front end. Some of them are getting rendered from back end. And I will come to this backend part in the later component where we are talking about UI backend. So for example, when we talk about user interface, what are the user interface? The URL bar, the address bar, the forward and backward button, the hamburger menu button, the bookmark button, the tab button, the cross sign on the tab button where you close your tabs. Those are the components that belongs to the front end, and that is getting rendered from the front end side. So that was the quick intro for the user interface. Next point is browser engine. But before we talk about browser engine, let's skip it for a bit so that we can understand it better. Let's skip it right now and let's go to rendering engine. I will come back to the browser engine for sure. So when we talk about rendering engine, what is exactly happening? Just in simple ways, rendering engine is just rendering your UI, rendering your HTML, CSS to display it on UI. When we talk about rendering engine, it is just about rendering your HTML and CSS, or let's say parsing your HTML and CSS and HTML, CSS, and it will just parse it. It will do a lot of syntax analysis, lexical analysis, and then it will show it on the UI. So when we talk about rendering engine, you can say it just displays the UI on the user interface, the UI of your website or whatever you searched on the browser. It will just display in the user interface. But now I am talking about it will parse the HTML, CSS of the website. But who is telling rendering engine about what user has requested? Here we go back to the browser engine. That's what browser engine is doing. Browser engine is simply telling the rendering engine that, hey, rendering engine, user has requested for this website, right? And then it will go through all the layers where the HTML and CSS parsing will happen. We will go back to the networking part. That is the next part. As we all know, we all know a bit of networking, and I'm not going to deep dive into networking here, but let's close this part by just saying network calls. All networking here is doing is network calls. You requested something on the UI, it will do your HTTP and HTTPS request. But then it comes to JavaScript interpreter. When we talk about rendering engine, I say, okay, this is going to just parse your HTML, CSS, but website have more than HTML, CSS. What about JavaScript interpreter? So as you already guessed in your head, JavaScript interpreter is going to execute and render your JavaScript. But now you have your JavaScript rendered and you have your HTML, CSS rendered too. Next is UI backend, but what exactly is UI backend? This is confusing word, UI backend. So now, when it comes to UI backend, let's go back one step back, and you open the browser and you see something. You type something on the URL. Let's say you typed google.com, and it shows a result in the window. Imagine that window. That window is something that is getting rendered from UI backend. That is not part of user interface. Yes, the URL bar is part of your user interface that is getting rendered from front-end side, but the window you see on the browser is part of UI backend, and it is getting rendered from backend. So we talked about, all this small stuff like user interface, rendering engine, networking, interpreters, and all. But when we talk about browsers, something is still missing, right? I am on browsers. I am browsing. I save files. I deal with local storage, and I deal with file systems. I also deal with a lot of mechanism where it comes to saving the data. I also download files, but where all this stuff is going? Yeah, as you might have guessed in your head, it is all part of data persistence. All the cookies, all the local storage part, all of these are part of data persistence. And my friends, this is all about the browser components for now. All right. If you have any questions, feel free to contact me on Twitter or later in the networking session.
Congratulations, Rakhi.
Thank you
very much. Beautiful story. I think because that you chose the Lightning Talk version, so we're going to chat more about that after after the meetup, so after the talks. So you're welcome to join our networking session, and I hope we're going to talk there soon. So thanks a lot for the talk. And now next person. So Tiago is joining us. Hello, Tiago.
Hello. Can you hear me? Can you see me?
Yes, I can hear you and see you. Unfortunately, my light is over, and you're still 2 hours now, 1 hour actually behind me, because it's now, I guess, 6:50 in Portugal, right?
Yes. Yeah.
Okay. Well, I today I learned from you that you're actually only 30 minutes from the ocean, so that's amazing place to live. So Tiago, your time starts now. 25 minutes for the talk and 5 minutes for questions to the longer talk. So good luck there, and see you soon at the question and answers.
Okay. Of course, right now something in my computer stopped working, but
okay.
We will see how it goes. I may have to find another way to do something. Okay, let's start.
Okay, so let's start.
Okay, you can see my screen, and let's go. So I trust that you can see my screen now. So I am Tiago, and I am going to talk about VueJS and how we can use it with robots, especially fluffy robots. And by doing so, we are also going to dive into Vue 3 that just came out to beta, and so we can already use it. So about the future, we don't know much about the future. We know that it will probably have robots, and we hope that they will be nice robots. So robots, okay, cool. Also, it cannot be much worse than 2020, right? So I think the future can only go better. So who am I? I am Tiago. I love robots. This is me in another presentation, also playing with robots and Vue.js. And also, if you are a robot from the future, seeing this video, know that I am on your side. So please don't kill me. You can put me in your people's zoo. But okay, I'm on your side, okay? I am saving a robot, and I risk my life to save the robot. So I also love Vue.js. I also love NativeScript, which is a framework to develop native applications using JavaScript and also using Vue.js. And I also love irc.com. That's my company right now. And we are trying to bring IRC to the 21st century and make like a modern clients and solutions based on IRC. So VueJS version 3. I don't know if many of you have already played with it a bit, but it was built for several reasons. First of all, a very good reason to use Vue version 3 is that you can extract the reactivity part. So all that part that we love about Vue, that everything is reactive. So when our data changes, it updates the UI and vice versa. All that works on top of a bunch of reactivity code. And now you can actually use that as a standalone package. So you can use it on your Angular or on your React or even on your Node application. So what we are doing today is we are going to use it with robots. So there's that. One moment. Okay. Also, VueJS version 2 was quite nice. But once you want to build something more complex, you had to resort to mixins, which kind of have like some weird behavior. and sometimes it's hard to know where the behavior is coming from, especially if you have several mixins in the same component. Or you could also use something like scoped slots, which is not very friendly. Every time I want to use scoped slots, I have to see the documentation, because it's not very intuitive comparing to the rest of the VueJS API. And also, Avenue took this opportunity to rebuild VueJS using proxies, which is a newish JavaScript ability to observe objects. So you can put a proxy on top of a JavaScript object and catch anytime that a property in that object is set or retrieved. So it's kind of a rebuild from scratch using these proxies, which make everything more performant. So let's play with robots. If you want to use JavaScript with robots, you are talking about NodeBots. So that's the keyword that you will have to put in Google to learn more about how to use JavaScript with robots. Specifically, you can use Johnny5, which is a very nice and clean API to play with all types of hardware, like Arduinos, Raspberry Pis, and pretty much all type of hardware. And the API is very simple. You will see next. But so you have NodeBots. But if you add Vue, then you have VueBots. So this is a word that I made up. I hope it catches on. So VueBots, robots built with Vue. So let's get started with reactivity. Okay, and this works. Wait, okay. So I hope you can see my code, and I hope you can see a bunch of wires right here. So just a little explanation. Ignore most of that stuff. For now, you can see I have an Arduino here, which is connected through USB to my computer. And I have a LED over here and a button over here. And let's start doing some stuff. So first, let's understand a little bit just the basics on how Johnny5 works. So with Johnny5, you have to import 5, which is the Johnny5 API, and then the board class. You have to create an instance of a board. A board kind of represents a piece of hardware, in this case, the Arduino. And then you can make this callback. So when the board is ready, in the ready state, you can access the hardware in this way, which is very simple. I am creating an LED that is connected to the pin number 2, which is this orange wire right here that I covered in tape for extra security. And so I create this instance, and from that moment on, I can use all sorts of functions. In this case, I'm only going to turn the LED on. And so all I have to do is run node, and our LED is on. So cool. That's how the Johnny5 works. It's a very simple API. But now let's start making some stuff with VueJS and the reactivity module. So I am importing the reactivity module right here, and I am starting by creating a reference to a value. When you create a reference, you kind of make some value reactive. So if you want to make a primitive value reactive, you have to use this ref so that VueJS can track when this value changes. And then, so consider this LED-on as a piece of data that you could put in the data part of your VueJS template. Okay, so then I am creating an effect. An effect is like a watcher or like a computer property. An effect is a function that is executed every time something inside it changes. So this effect will do the following. Whenever the value of LED-on changes, it will turn on. If the value changes to true, it will turn the LED on. If the LED changes to false, it will turn the LED off. So think about this. It works like a computer property or like a watcher function. In fact, in VueJS 3, the watcher uses this effect function in the underneath. So then I have this simple function, this set interval, only to switch the value of LED. So if it's true, it turns into false, and vice versa. And I am running this every 500 milliseconds. Now let's see how this works. Okay, it works. Our LED is blinking, and right now I have to pause for a moment and take a moment to appreciate what's happening here. Right now, our VueJS code is entering into the physical world. So with VueJS, we usually only move a few pixels on the screen, but right now, VueJS is turning a LED on and off in the physical world. I don't know if haven't you ever thought that people would use Vue to do this kind of stuff, but here we are. Cool, we have something. Let's play with something else. Like I said, I have this button right here, and I want to play with it too. So I am copying this bunch of code. So I am not a junior engineer. I am a senior engineer. So this is how senior engineers do live coding. So Piotr, this is for you. We don't do live coding. It's too dangerous. Don't do it. It's safer this way. So this is how seniors do it. Okay, so this is pretty much the same for a button. I am creating a reference to the state of the button. So this is a string that will change. And then I am creating the Johnny5 instance of that button that is connected to the pin number 4, somewhere around here. And then I am creating a bunch of listeners on Johnny5 so that whenever the button changes, it will update the value on this reference over here. So it will update. And then I am using the effect function again only to log this behavior, so we can actually see whenever something happens. So here we go. And as you can see, the button has 3 states: up when it's up, down, and hold. So when I press for a while, so here we go. And you can see in the terminal, it's working. So okay, cool, it's working. So now we have a very simple output, which is the LED, and a very simple input, which is the button. How can we mix them up? We can do that with a computed property. So let's say that we want to make the LED on whenever the button is pressed. We can use that. We can do that with a computed property. So this LED.on state, instead of being a simple reference, it can be instead a computed property. So a computed is a function that will return something, and it will run whenever something changes inside that function. So I have to delete this. I am also going to remove this set interval because I want to use it. I want to change the value of LED on whenever the button state changes. I also have to move some code around because I am using button state over here, so I have to declare that state here. So okay, cool. Let's see if it works. Okay, it works. So right now, whenever the button state changes to down or to hold, to the down or hold state, LED on will be converted to true, and then this effect over here will turn the LED on or off, according to that. Okay, cool. So now we have a button that moves something. Cool. Let's do something else. I also have this other file. Now let's use another bit of hardware, which is this potentiometer. This is like a button, but you can rotate it, and so you can use, like, instead of only on or off, you can use it to set a range of the values. So this is what I made. I am also creating an instance of the LED on pin number 2, and now I am setting a blink to be like the frequency of the blink. So when I run this code, the LED will be set with the frequency of this reference. So it will blink every 182 milliseconds. Yeah. So, but I am also creating a sensor to instantiate this piece of hardware, and whenever this value changes, I am going to change the value of this reference, of the blink reference. Let's see this working. Okay, so right now it's blinking very slowly, about once per second, but once I reduce the blink time, it will start blinking faster and faster. So cool, works. Okay, another example, very similar to the previous one. The only difference is that I am using a potentiometer to do all this. And as you can see, this is throwing a bunch of events, but VueJS deals with all of them, no problem. Okay, back to the slides. So we all love VueJS reactivity, but we also love components. That's the way that we are used to create our applications and try to divide our application into smaller components that are easier to reason about, and also components that can be reused, so we decrease the amount of code and complexity that way. So, but can we use components with this kind of hardware? Well, in order to use components, we need a runtime, and VueJS version 3 comes with a runtime called runtime-DOM for the DOM, and but we can use another runtime called runtime-test. So this is a very basic runtime that is only used for the unit testing inside VueJS. But since it's very basic, we can actually use it for this kind of stuff. So the runtime is the package responsible for creating the components and making sure that the component lifecycle works. So it implements the component lifecycle, and the rendering, all that is done in the runtime the package. So let's see how it works. Okay, so I have another file right here, and I am creating some components right here. So again, I am importing some stuff from the reactivity module, effect and the reactive. I will tell more about that later. And then I am importing some stuff from the runtime. So things like the render, the h function, which if you ever built functional components in VueJS, you already have used these functions, but previously they were already in the scope automatically. But with VueJS 3, you have to import everything, which is, I think, better, because there are no magic state floating around. And so again, I am creating a 5 instance and a board instance, and I am creating my first component right here, the component LED, LED. So this is my component, and I could use the data right here, etc. But VueJS 3 has a new function called setup that allows you to do a bunch of things that in VueJS 2 would have to be split apart. So sometimes you have to put something on the created, then that uses something that comes from a prop, and then it updates some data. And so in order to follow the state in your component, you would have to look in several places on your script. But with setup, you can do it only in one function. So it's one function that will create your component. And you can do pretty much everything that you could do in in your data, in your mounted and created, etc. And this function will return another function, which is the render function for this component. Of course, the render function for a LED is pretty much nothing. So I am returning an empty function. So in our LED component, I have only to create an LED instance of the 5 library, and then it will receive a pin, so that I know which pin the LED is connected to. That comes from the props. So I already know right here what are the props on this component. And then I am again using the effect, so that when a prop called on, the on prop is on, the LED is turned on, and when the prop on is false, the LED is turned off. So this is my first component, the LED. In a similar way, I created a button component that also has a setup method, and a button component also receives some props, namely for the pin number that the button is connected to. And then I am also grabbing this emit, which is a function to emit events to the parent. So I have to explicitly include the emit function. And I am just listening to a bunch of events on the button and using emit to send them to the parent component. Okay, so these are my basic components, and now I have a parent component, and I have to go a bit faster. And now I have my bot component, which has a bit of state. And now I am using reactive instead of ref, because a reactive is when you want to make an object reactive. So if you want to use an object and listen to changes inside that object, you use a reactive. And again, I'm using some effects, and I'm using an effect to change the state of the LED whenever the button is pressed down. And then I return my render function. So this component called bot will actually have 2 children, a LED and a button. The LED has 2 props. One is the pin number, the other is the LED on, that will tell that whether the LED is on or off. And the button will have another prop that's the pin, and a function on change. This will actually be the listener. So whenever the button emits an event called change, and I am emitting this event right here, it will change the state of the button. Okay, so whenever the button changes its state, it will change the state of the button right here, which will then through this effect change the state of LED on, which is passed on the prop to the LED. And then let's see if this works. Okay, again, it's a very simple work, but now we have components. And this is pretty cool, because now I can actually grab these components and combine them and use them in different ways. And I will do that in just one moment. So I really wanted to make something special with these components. and with this Arduino. So I am happy to announce the first ever VueBot. And since it's the first ever VueBot, it's called VueBot 3000 because it's the first. And for this VueBot, I took inspiration in the greatest actor of all times. And I wanted to make this robot feel like human. And so I split the entirety of human emotion into two axes. One goes from sad to happy, and then you can also have two states, the evil and good. So when you are feeling happy, and it's a good feeling of being happy, so you are feeling good, everything is great, you feel the breeze on your face, you are happy, you are relaxed. But you can also be sad, but it can be a good type of sadness. So when you are missing someone, or when you are feeling sorry for someone, so you are feeling sad, but it's actually a good feeling of being sad. But there's also when you are feeling sad, but also evil. So you are kind of angry. You want to destroy something because you are sad about something, and you are feeling like desperate. And then there's the worst kind of feeling of all. It's when you are feeling evil, but you are happy about being evil. So you are feeling sadistic. You want to destroy something just for the pleasure of doing so. And so here we go. I don't know if you are ready. This is the VueBot 3000. Dun, dun, dun. Okay, VueBot 3000. So the VueBot has a couple of components, and I will show you first how they work. No. So, okay, in order to change the happiness of the VueBot, I am using this potentiometer that I showed before, right here. And when I turn it this way, you can see that the robot is happy. It has a smiley face. But if I turn it the other way, then suddenly the robot is very sad. It has a frown face. And there are all types of feelings in between, like this. I am waiting for the bus. Oh no, it started raining. Oh, I brought an umbrella. Okay, so you can see all kinds of happiness states. And also, you have two eyes right here. So green is when the robot is feeling good, and red, it's when I press the button right here. Okay. This is when the robot is feeling bad. So green, it's the color of view, good. Red, it's the color of another framework, so evil. And okay, this is how it works. And it even does more. As you can see, the LED is blinking. I will change to good because it's freaking me out. I'm like, okay, good. So the LED is blinking. That's because we blink our eyes. We don't want to. I wanted I wanted the robot to feel more human and not like a static robot like Mark Zuckerberg. But also, we usually blink when there is more light. So if the robot is in the sun, I am pointing a flashlight, you can see that it starts blinking faster. And if it gets darker, it blinks slower. Cool, right? And by the way, all that comes from this nose, which is actually a light sensor. So cool. This is our VueBot. How does it work? This is the code for the VueBot. Okay, so right here, I created in this file components. I created a bunch of components that I have been playing with. So I have your LED, your RGB LED, button, a servo. This is the motor that is powering his mouth. The potentiometer, it's another component, and the light sensor, all things like that. Okay, so this is kind of my component library, and now I can use it. I created a bot object, a bot component with a state that's kind of his brain, and the state has those two components, those two parts: the happiness level that goes from 0 to 100, and the alignment, either he is good or evil. And then I created an effect so that we can see what's happening around here. So then I am moving the mouth according to the happiness. So the mouth engine, it's a function of the happiness. And then I am also creating an eyes component. What's that all about? I think it's better if I show this right here. Okay. So I have the brain component in this robot, and the happiness is controlling the mouth engine. But also I have an eyes component. This is kind of some abstraction that I made, so I can split my robot into smaller components. And the eye component has the two LEDs, the red one and the green one. And okay, let's see. So yeah, so this is my eyes component. You can see it has two child components, and an LED on pin number 7, and then it changes the property on of that LED according to the alignment. But also I have this is blinking, and you know, usually you are not aware of when you blink your eyes, because that is something that happens kind of automatically in your cerebellum. This is kind of a part of your brain that is responsible for some automatic stuff that happens on your body. So it's kind of a nice way to see, because sometimes you have a bit of behavior that you want to put aside on your application. You don't want to always be thinking about it, because you know, something that's better if it's a bit to take away on the side. And so this is how you can do that with VueJS 3. You can use a use function, so and make that part of your state. So right now I am importing a bit of state called isBlinking. So when the eyes are shut while blink, and I'm using a function that comes from another file called Cerebellum, and this file only returns a useBlink, and it has its own internal state that's blinking, and it creates its the sensor for the light, and does whatever it needs to. I have to rush this a bit, and yeah, so it works. So I am importing a bit of state that is managed from somewhere else. So, what did this experiment to talk me about the composition API? First, that the reactivity module is very useful by itself. So you can use it and think about other ways that to use the powerful reactivity of Vue, but outside Vue. Also, it brings more potential to separate app logic and to reuse that logic using those use functions. And also, throughout all this code, I never used the keyword this in the JavaScript. This means that the composition API makes things more functional, so you can program in a more functional approach. And also, there is like no magic state coming from something called this that sometimes it's harder to see how it works. It's very declarative. You always know where things are coming from. And also, I could, from this base, I could increase the functionality of these robots very simply. Maybe the morale of the robot would be a computed property. Maybe the robot could fall in love, and that would be a function of the heart. Maybe the consciousness could be a reactive object, including several properties. I don't know. Maybe I could have a be nice. That's a reference, so you can change from on off. Or maybe I could add a Sunday machine to this robot, and that would be only like adding another component with a prop for the flavor. Super simple. So I could increase the complexity of this robot in very different and cool ways. And also, Vue bots are cute. So, yeah. And thank you very much. This was my talk, and that's it. The code for all this is on my GitHub. You can check it out. And thank you.
Congratulations, Tiago. Fantastic work. I'm so happy that this robot was so cute and it had so many functionalities delivered through Vue. I'm really impressed. Do you have any questions, Tiago? As you saw, the feedback was very positive. People are amazed about that Vue.js can interact with it. And I hope you can tell more. Oh, there is one question from Martin. Tiago, what is VueBot 4000 going to do?
I don't know. Maybe it will walk my dogs, or it will bring the souls of my enemies. I don't know. I am
Okay, thank you very much, Tiago. Fantastic sense of humor. I wanted to see. I wanted to see you soon at Remo. So hopefully, Ania will be next now. So Ania, are you with us? Can you hear me?
Hi. Yes. Hello, everyone. Hello from London.
Hi, Ania. I'm happy to know you. I never saw you live. However, we met online, and I met you through because you started to publish some streamings how to code games, old school games, and it was so cool that I immediately thought that I could invite you here to WarsawJS, and I'm very happy that you're joining us.
Yeah, thank you so much for having me. I'm really excited. Yes, I mainly make games on YouTube. I started out just teaching people how to sort of perfect their fundamentals in JavaScript by building classics such as Tetris, like Space Invaders. But now I do games like Candy Crush and stuff. So if you're interested, today we're going to be talking about Flappy Birds as well. But it's only 5 minutes, so I'm going to try cover as much as I can. But obviously, I've got like a whole YouTube tutorial on it if you're interested too.
Okay, so good luck then. Only 5 minutes. I hope you also will stay for us to the networking. However, no questions after lightning talks. So good luck, and 5 minutes, whole 5 minutes goes to you. See you then.
Thanks, Piotr. Okay, let's do it. Okay, so I don't know, can you see my screen? Yes, okay. So Flappy Birds. I'm really excited today to show you my project of Flappy Birds. Now, this is a collaborative effort. I did get together with one other developer, so I'd feel bad if I didn't give her a shout out. Hey, Shushtika, thank you so much for coding this game with me. What we did was essentially take a classic multiplayer, classic game of Flappy Bird, as you can see here. I don't know if you can see me playing it. Let's go ahead and play Flappy Bird. So, woo! But then we've actually gone and using Albi Realtime made it multiplayer. So I'm going to talk a little bit like meta about everything, just with a slideshow. So what we're going to be doing today is I'm going to show you like a small overview of the code, not too much, obviously, because we don't have that much time. Then we're going to talk about understanding network strategies, okay? So network strategies for players, how to communicate with each other. Then we're going to talk about making clients, so players and the game server communicate in real time over WebSockets, and about the concept of presence. So let's move on. So I guess let's start off. Naturally, for a multiplayer game, you might think of a P2P or peer-to-peer strategy where all the players are connected to each other in a sort of spider web or, you know, anti-Christ sign, whatever you're into. We're not going to go too much into this, but we are not going to be using peer-to-peer for this, as it's too much. As you can see, one message is sent by any one player to 4 different points. It's expensive and will increase with n by n times based on the number of players. So it will essentially give space for O(n) squared time complexity. This is not good. This is not what we want. So we are going to be making this game with a much simpler client-server game architecture. In this model, each client sends its state over to the server, which collates it all together and publishes it. Okay, the state is updated continuously at high frequency, making the game appear super smooth. As we are only sending one message, or n, per player, this is a much more efficient way of sending data than a P2P strategy and gives rise to the O(n) time complexity, or linear time complexity. Now let's talk a little bit about how the client and server will communicate. We're going to be building this using WebSockets, as HTTP request response cycles aren't really suitable for the high frequency communication we're going to be doing. For this, we're going to use Ably. So Ably, it's an infrastructure and library that we're going to use that powers real-time functionality. So I'm just going to show you maybe some code about that. So obviously this is the game. It's quite fun. If you want to take this game later, you're more than welcome to. It's on my GitHub. You can make it harder just by increasing gravity like this, you know, like if you want to put levels to it, that's another fun way to like take it and level up with your friends. Yeah, so essentially here, you can see here we have 3 libraries as well. So all we do is use 3 libraries. What am I doing? Oh, you don't need my API key. But essentially what you're doing is using the AB real-time library. So if you want a closer look at this, again, I'm not going to go into too much of it just now. Please do have a look on my GitHub for it. Okay, so before we move on, I just want to point out channels. For this game, we're going to have multiple channels. So we're going to have 1 channel for the game and 1 channel for a player. Just think of it like streaming data back and forth, I guess like Deliveroo does. Do you know what I mean? Like when it sends your location, but then it sends you locations back and so on. So that's sort of what we'll be doing here. So we're gonna have all these channels here, and then other players, obviously. I think we're gonna have as many up to 50 players or something. So that's quite fun. And we're also gonna be dealing with the concept of presence. Now, the concept of presence, this will allow us to know if any new client gets connected or disconnected from our application. So we're gonna use it to know if we get new players, players leave or die. So that's quite cool, that's quite fun. That's another thing that we're gonna be using in this game. So I don't know if you can really see it. It's a bit small. I wish I could zoom in, but I don't really know how. So the fun thing about this is actually that you can sort of see here like a little what's it called? Like a less transparent player. So each time you gain a new player onto this, what is essentially happening is you'll get another Flappy Bird, but a little bit more transparent, which is so cool. And then you can obviously add, you can see all the live leaderboards. I mean, I'd love to play this live with you guys. I think when I did it last time, we got at least 50 people playing, all the high scores, people changing their names. Obviously nothing too rude. There is actually a filter that doesn't let you like say swear words, which is quite interesting. But yeah, that's the game. So I hope you have enjoyed this overview. It was really fun making it, and if you're into games, if you just want to practice your JavaScript or try something a little bit harder with using the Albi real-time library, then please definitely have a go.
Congratulations, Ania. I saw a first comment that your API key needs to be changed as it can be just.
I'm going to deactivate it, can't use it.
Yes, yeah, and it happens. However, yeah, thank you very much for this overview. I will visit your GitHub too, and I'm very curious about this particular code. As yeah, it looks really cool and awesome. Would you stay with us for the networking?
Yeah, definitely. If anyone's around, please join us for the networking. It's gonna be really fun.
Okay, fantastic. So I post now the link to virtual venture cafe. So thanks for the hospitality of Warsaw Venture Cafe, and yeah, and we can meet there later. And now some good news for you guys, because Piotr Sławiński has solved his issue and he wants to show how to resolve his blog. Hi, Piotr.
Okay, hi. I guess you can see my screen. Do you see my screen?
Yes, we see it. You can start.
Yes, you see my screen. Okay, so I consulted the inner developer. I meditated a little bit. I used every trick in the book, and I got it. I got the bugger. So, behold. And that's it. For a reason yet unknown to me, the unclosed self-closing tag was throwing on some invisible error, which I did not see in the terminal, and I didn't know where to look for it. But in the end, as you can see, the markup works. We have our blog posts. So that's what you get when you develop stuff without linters, I guess. But that would be actually a pretty good exercise for me to check the stream, to check the video of my work and look for it, because it's amazing that it did not show up in my terminal. Okay, so thank you very much.
Thank you. Congratulations for solving the problem.
Yeah, I redeemed myself.
Thanks for redeeming.
The hope is not lost.
Very positive conclusion of our meetup. I hope you can join these two videos somehow to show it later. As you can see, you have some congratulations already. And if you have any questions to Piotr, this is the last chance. So please write on YouTube now, and I will read the questions. Okay, so you have great applause and no questions now. So please join our venture.
Applause is good for me. Okay, see you all on the
Reno.
drink networking.
What I can say, the last words for today. I'm again, thanks a lot to our sponsors of the event. So here are the sponsors. And so Tencras, Prisma, Fresha, Packhub, Sumo Logic, and Xfunk. And also thanks to our sponsor, to our partners, we have all the remaining cool stuff. So the JetBrains license, the district call today, so our Remo. So you're all now invited to Remo and to have some chats and to network with our speakers. So thank you very much, and as usually, I invite you to the next WarsawJS Meetup. It's going to be always on the second Wednesday of every month. Since 6 years, it's always like this, so nothing is going to change. So thank you very much for today, and see you soon on our next events. Bye.